Hi viewers, welcome to our YouTube channel Electrical Lectures. Today we will be discussing about the inverse Laplace transform, which is a very common practice to compute the impulse response of any continuous time plant or system, and also to analyze a plant or a complete closed loop system in terms of the transient response. So let us start, and as an example let us consider this transfer function g of s given by this particular expression. The most common practice that is used to find the inverse Laplace transform is through partial fractions. So the first step is to compute the partial fraction coefficients by using the well-defined procedure. So what is that procedure? First of all, we will write this g of s in terms of the partial fraction coefficients for each factor. So that will be s plus 1. We will write the complete numerator and denominator on the left hand side, and on the right hand side for each factor we will use a coefficient. For example, the first one is a, so it is a over s plus b over s plus 2 plus c over s plus 3. So for each factor in the denominator we have dedicated a coefficient. Now, as per the partial fractions procedure, we will multiply both sides with the denominator. So when we multiply, the result is s plus 1 on the left hand side. On the right hand side we will have a into s plus 2, s plus 3, and then b into s plus 3, and then c into s plus 2. Now we will compute all the roots of the denominator and put all the roots one by one. So from here the roots are s is equal to 0, s is equal to minus 2, and s is equal to minus 3. So let's call it s1, s2, and s3. Now for each value of the root we will compute the coefficients by using, let's say, equation 1. So for the first root, s1 equal to 0. On the left hand side we will have 1. On the right hand side, for s is equal to 0, the second and third term will be 0, and we are only left with the first term, which is 0 plus 2 and 0 plus 3. So from here you can easily see that the value of a comes out to be 1 over 6. Similarly, for the second root, which is minus 2, the left hand side becomes minus 2 plus 1, and on the right hand side from equation 1 you can see that the first term and the third term will be 0, and we are left with the second term, in which we will substitute minus 2 in place of s, so it is minus 2 plus 3. So from here we will get b is equal to 1 by 2. This is the second coefficient, and for the third coefficient we will substitute the third root, which is minus 3. So from here it is minus 3 plus 1, and now the first and second term will be 0, and we are only left with the third one, which is c into minus 3 and minus 3 plus 2. So from here you can see that the value of b comes out to be minus 2 over, value of c comes out to be minus 2 over 3. So these are the three coefficients, and we will substitute all these coefficients into the main equation. So now we rewrite g of s by substituting the coefficients as 1 by 6 over s, this is the value of a, plus 1 by 2 divided by s plus 2, plus minus 2 by 3 divided by s plus 3. So now g of s is in simpler form. Now we can directly use the Laplace transform table to compute the inverse Laplace transform. For this particular expression we need to have two Laplace transform pairs, and those pairs are that the Laplace transform of 1 is 1 by s and the Laplace transform of e raised to power minus at is 1 over s plus a. These two Laplace transform pairs will be sufficient to compute the inverse Laplace of g of s. So for the first term, we will use this particular transform pair, and the answer would be 1 by 6. Let's say we call it g of t in time domain. And for the second one, 1 by 2 is constant, and in place of a we will write 2, so it will be 1 by 2 e raised to power minus 2t. And for the third one, minus 2 by 3 is constant, and a is equal to 3, so it will be e raised to power minus 3t. So this is the time domain response, or the impulse response of this particular plant or system. And from this time domain response, you can further compute and further analyze the transient response of this particular system. In the next videos, we will be talking about these transient response and time domain parameters, including overshoot, settling time, rise time, etc. Thank you for watching this video. Stay tuned to our channel, Electrical Lectures.